Hello, everyone. Welcome back to Streaming Alchemy. I'm John Mahoney, and on today's show, we're going to be taking a look at Birddoor Cloud and SRT, a very popular set of solutions and technologies that are used for remote productions and other remote connectivity between video locations. So, before we get to that, though, I'd just like to remind everybody we always welcome your feedback, your questions, your input. So please feel free to drop anything in the comments below, and we'll definitely discuss it right here on air. Also, if you'd like to call into the show, we left a call-in link in the show notes, and it's here on the screen. So if you'd like to join us on air, we'd always love to have you. All right, so let's get started. One of the things that we've been seeing a lot of is, and I think this has been through the past year, has been different styles of remote based productions. And by a remote production, what I really mean is that there are video sources that are being sent from a different location than they're being processed. So this can be everything from productions that are run out of AWS to productions that are run across multiple locations. And we've spoken to a lot of folks about it. And one of our clients actually asked us to take a look at Birddoor Cloud, which we were familiar with but really hadn't dived into. And when we saw that, we thought it was really an excellent model for how to combine one of our favorite technologies, NDI, with SRT, which is Secure Reliable Transport, a way to move data across unreliable networks in a reliable way. So what I'd like to do is jump in and take a look at Birddoor Cloud as an architecture, and then dig a bit into SRT, and we'll sort of go from there into how you could set this up on your own. So Birddoor Cloud is a general model that we have here that will work across multiple locations. So it doesn't have to just be from one location to a second location. You can have multiple locations that are all interconnected. And the general terminology that is used is each of these remote locations here are called endpoints. And when they talk about an endpoint, it really means it's a single location that can both send and receive video and audio. And the model it's using is that you will take NDI sources that are found at any of these locations, and you'll be able to say, I want to make this NDI source available. And at another location, they can come and say, I actually want to pick up that NDI source and start to bring it into my location. And what's great about the way this works is that the sources become transparently transported across the internet. So if I had a camera over here in what they call machine room, if I had a camera sitting over there, and the camera was named Machine Room 1, and I subscribed to that camera in another location, say Studio 2 down here, I would just see that as an NDI source on my network called Machine Room 1. And that really creates a wonderful transparency. So if I were to move to different, to different locations, I can still use the same nomenclature. I don't have to rename everything just to make it work across the internet. And the transport protocol is what we call SRT. So we're connecting cameras via NDI and transporting them across the internet to other locations using SRT. So let's talk, before we get into SRT, let me just welcome everyone. So we have Richard, thank you, from Sacramento. Rudy, great to see you as always. Mr. J.S. Gilbert, good day. Thank you for joining us here. So, SRT. SRT is a transport protocol, and I want to be very clear because there can be a lot of confusion. All a transport protocol does is takes data packets from one location and delivers them to a second location. So it doesn't really care what's in those data packets. And what makes SRT a special transport is some of the parameters that they've baked into how it operates. So it is very fast, relatively speaking, for a wide area transport. It is also reliable. So it uses an underlying protocol called UDP, but a variant of it that is called reliable UDP. And that means that if I'm sending packets of data from location A to location B, and some of those packets get dropped, it has the ability to go back, re-request those specific packets, and sort of fill in the gaps, but it does it all within a time window. So if it can't replace those packets in the time window it allows, usually something very, very short, then it will just go ahead and you'll get skips or other things. So as a protocol for transporting data, it has a lot of tunability. I can turn around and say, I'm willing to accept more latency, basically create a bigger window that I can recover data in, but things will be more delayed on the remote end that's receiving it. So if I say I have a 500 millisecond window, that's my latency, that means that for half a second after the first packet goes out, it won't be played back on the other side. That half second is basically everything's held to try and make sure you can do recovery. And that's what makes it very powerful for this use case here. But unlike something like NDI Bridge, which we talked about a few weeks ago, that's designed around moving NDI across the internet, SRT, and the way it's used in this case, is all around letting you create whatever encoding scheme you want. And like I said, it doesn't care what the data packets are. So whereas NDI Bridge is going to take NDI encoded, either HX2 or full NDI bandwidth, full bandwidth NDI, it's going to transport that across. Inside SRT, I have the ability to put my own video encoder in play. And so this means that I could take and do something like H.264 or H.265 to do higher end compression. It could be MPEG, TS. It also means that I can be open to different types of protocols in the future. So there may be different things you will want to use for encoding images, encoding slides. All of those things, it's adaptable because SRT is fundamentally encoder agnostic. And so the way this works then is you take a video feed and an audio feed, you encode it, you then use a computer to talk to BirdDog Cloud or any other transport mechanism you're using. And so if we're doing SRT, that SRT system will talk to a system at a second location, which will do all that handshaking, packet recovery, anything else. That all happens between these two computers. And then once it releases that video packet, it gets decoded and then displayed. And what BirdDog Cloud is doing is it's wrapping the video encoder up as part of its software, but you can also use external encoders like NVENC and other types of things you can get on graphics cards. And it's taking the input via NDI. So this whole part gets really streamlined into a single application that's run on a computer. And based on the capabilities within that computer, you have different options for encoding the data that you have. And that same thing unpacks on the other side. So it's really a very efficient way to move data with relatively low latency, but tunable, both in terms of the codec and in terms of the overall latency you accept in the production. So hopefully that gives some clarity, sort of the underlying architecture and technology. So let's talk a bit about how you'd actually go about setting BirdDog Cloud up, because I think this is going to be interesting. They have a free trial. So this would be something that everyone could download and install and play with as much as you want. It's just watermarked. So in the free trial, that's the only indicator that it's free, but otherwise you get to experiment fully with this solution. So before I go there, James Redmond. So James, thank you for joining us. As always, I appreciate it. So to install BirdDog Cloud, you go to bird-dog.tv. I don't have that set up here right now to do, but that's just the location. You go into cloud and say, I want a free trial. And they give you a form to fill out. So you just fill in the general details, who you are, what country you live in, etc. And they will send you back an email. And in the email, it'll have a download link to the software, the BirdDog Cloud software that needs to run on your local system, basically your endpoint. And it'll give you keys you need, because it sends you keys for 2 locations, because each location is its own endpoint and needs its own unique key. So when you get that, you can download the software and do the install. And when that install is finished, what you're going to get is a special code. And what this code is going to do is it's going to identify, sort of physically identify, the system that you're running on and register that system as an endpoint with the BirdDog Cloud backend. So they know anytime this is routed, I'm trying to route packets to here, I know this is the system that I need to send them to. And so that gives that unique code. And then when you run BirdDog Cloud for the first time, it's going to come up and say, okay, enter your sharing token, or enter the code that you were just sent, and you claim that as an endpoint. So now it says that this machine owns this endpoint in the cloud. And you then go and you configure this endpoint. You'll sit there and go, what's the name I want to use? It gives you a directory for recording. You can put all other types of notes. And then what it has at the bottom is a license key. And that license key is one of those 2 keys that you will be sent from BirdDog when you sign up for the free trial. So what's the difference between this code that they send you and the license key? So the license key basically just says, this is me and I've paid for an endpoint. And I am associating this paid for endpoint with this location. And so the code up here is the location, and the license key is the paid for endpoint. So it knows it should respect that as an endpoint. And the thing is, you could take one license key, apply it to multiple endpoints, and as long as you're only using one of those endpoints at a time, so say you talk to 3 or 4 different clients, you could go and install them each as different endpoints, but using the same license key, and you could talk to any one of them at a time, and that would be fine. So that should give you the distinction between the license key and the endpoint. So probably the next thing to do would be to jump in and look at how this actually would be operated. So let me go here and see if okay, so here is the main input you're going to have when you are in BirdDog Cloud. And what this is showing you is these are all my transmitting destinations, and these are all my receiving destinations up here. So I have the ability now to sort of work in a matrix. And if I want to take something that's transmitting from location A here, so this is our company office, if I click here and say, I actually now want to create a connection between my company office, and here in our studio. So if I click that plus key, you now see something that lets me say, what do I want to connect? So what is going on to make this connection? And we can sort of go from the top, and I'll walk through it, but you have the ability to set up different sort of encoding configurations, and I'll jump into that in more detail. So we'll just, for now, just set this as default, but you can set up multiple different types of configurations for how you want to do encoding. And you can say, I want to send just a single source, or potentially you might want to create what's called a multi-view, which could be multiple sources bundled together on a single screen. And this will give you the ability to sort of send a reference that a director or producer may be using to see what's going on across multiple cameras, even multiple sites. And so you can send that up, set that up that way. The next thing is you say, how do I want this SRT connection to take place? And there are 3 different ways. We can talk about them as we go through this, but there's something called rendezvous, caller to listener, and listener to caller. So rendezvous as a connection protocol basically lets the 2 sides that are going to form this SRT bridge, let them figure out how they want to talk to each other, what ports they want to use. That can be dicey sometimes, and it won't necessarily work every time, but it is definitely useful, especially if there are firewalls on both ends and you can't do any port forwarding. The next is called caller listener or listener caller. These are really just symmetrical examples. And I should be really clear here for what these mean. This has nothing to do with the direction that video or audio is going to flow in this connection. It is all about how the connection is initiated. So when I have a caller and a listener, the listener basically comes back and says, I'm here on this port at this IP address, and the caller then just goes and connects to that. And the opposite way, when you have listener to caller, if I set myself as the listener, then the caller needs to know my IP address and my port that I'm going to be listening on. So it's really just symmetrical ways of looking at the same type of connection type. What makes this very, very useful as a model is that only one side needs to display and connect with a known public port. And this is important because lots of times in your studio, you have control of your firewall. You can come back and say, anything coming to this port, I want to route it into this system, which is sort of the normal port forwarding model. But you can't do that at a venue you may be at. You may have cameras at a conference center or a sports arena, and you don't have that option. You don't need it with this model. All you need to do is say, this is the port and IP address, and when those cameras or whatever other device you have come back, your studio is the only one that has to make any changes networking-wise to make sure those connections can happen. And that's usually pretty easy for most people. So the next thing is, now we're into the sort of the basics here. Which source do I actually want to connect with? So if I come here and say, okay, I want to take this PTZ camera, I want to give it a name, so I'm just going to call it Zcam 1. And the other thing they give you is the ability to set up an NDI failover source. So if for some reason one camera fails, or I have multiple connections from a single location, I can actually have a failover source that I'm going to use. So if the one camera goes away, it'll automatically in the cloud switch to the second camera. Very useful, especially if some of the connections you have may be marginal for this. So when I have this set, then I can say, what is it that I want to let this do? I would like, PTZ control would be great. I want to pass tally. You could also pass alpha channel. So if you were sending something from another computer that embedded sort of pre-multiplied alpha channel into the video signal, you could accept that as well. I can tell whether I want audio. or not, or if I want just audio and I don't want to take the video feed. And then you get into sort of the mechanics. So what port am I going to do this connection across? Things like queue size is, the total number of frames, so that is tied in sort of to latency. So when I queue up 10 frames, that's 300 milliseconds. I'm setting my base latency to 120 milliseconds, which says I'd like everything to get to the other side within that 120 milliseconds. And then the SRT overhead that you can set here is all around how much overhead and bandwidth do I need to do all of the traffic management, all of the signaling, and all of the error recovery with my SRT feed. So if you have a poor line, you may need to use more of that line for error recovery, which kind of makes sense. And you can say whether you allow packet drop or not. So packet drop means if something fails, do I want to keep going, or do I want to go to my failover camera? The other thing is you have encryption. So SRT allows you to have either just raw bits going, or you can tell it use different levels of encryption. And the encryption is just going to be slight additional overhead and slight additional bandwidth, because it's the encryption process adds a bit to the size. But generally, if you're not worried, you can leave it off. But if you are, it's not a big penalty for adding encryption to get that extra security. And for some people, that may be important. Corporates that are talking internally that may have confidential information, that may be something that is significant for getting that done. Then the next thing you get to say is, what video decoder do I want? And you can tell it work automatically, or you can tell it, gee, I'd actually like to use my NVIDIA graphics card to do the decoding. QuickSync is an Intel based solution that's based into a lot of their CPUs, called QuickSync, or it can just be done in software. So the more you do in hardware, the more CPU cycles you have on your system to do other things. So that can be helpful. So normally, if we were doing something, we'd use NVDEC, because that's pretty much unlimited decodes on any of the NVIDIA GPUs. And at that point, when you're all set, there's other things for different timestamps and other types of logging. You can just go and say, I want to connect to that site. And as you can see now in the interface, it's showing that the site I've connected to it, and it is showing me the throughput we have coming to and from the camera. So if now I want to, let me see if I can, let me jump out of here for a second, shrink this down. Let me actually just go and open up a NDI Studio monitor here. So just give me a second. Okay. So now if I go to NDI Studio monitor here, so this is my camera here, but you'll now see in NDI Studio monitor, I have ZCam 1. If you remember, that's what I named it when I sent it over here. So now, by going to ZCam 1, I'm now going through Bird Cloud and delivering that video feed over here. And this is really great because I can give them logical names, and I can see them just as if they were local NDI sources. I don't need to do anything special. And that means my vMix systems, my TriCasters, my OBS, any of those systems, to them, this is just a local NDI source. So no special awareness there. It works seamlessly. So the other thing you can do, because if you remember, I set PTZ control. Now this is just a Zcam, so it's a box camera. I can't do the pan tilt, but I do have zoom control. So I have the ability to take and sort of zoom in and out with that. And now there is a bit of latency in here. So we found that in certain circumstances, it's about half a second. So it's not the sort of thing where you'd want to be able to, where you'd probably be able to do sort of granular control to follow somebody, using a PTZ. But it's certainly easy enough to set up presets and other types of things you may want to do, uh, one time and then just punch in the presets to grab different parts and actually have those transitions happen uh, for yourself. So if you want to move a camera across the stage, you could set up a slow preset and that would work fine remotely. The latency, once you trigger it, doesn't become an issue. So let me close this out and get back over here. So this now is going in one direction. I have things coming from our office location back into the studio here. But I can do it the other way as well. So I can come here and say, I would like to share sources from the studio. And now we have a lot of sources in the studio. So we have multiple bird door cameras. So we'll select this camera here. And I can do, so you see that was the last one we did. So I can do bird dog 1. And I don't have an NDI failover, but I can select Tally and PTZ. And again, all the things we did before, and I can set up the connection there. And so now with the license on each end, we now have signals moving back and forth. One camera here from the studio to the office, and one camera from the office to the studio. But you're not limited to that. So let me come back in here again. This is the camera that we have, the PTZ Optics Z-Cam, and we have that coming in. But I have the ability now to add more connections. So if I wanted to add a second source, I could just step in and say, okay, we have a, let's see, VLC. So I think this is just a video we have playing. So we'll just go video. And so now I've added 2 sources from the remote studio. And you can see this is all adding up below. And as long as I have bandwidth, I can keep adding sources. But bandwidth in this, remember, is multiple levels. So since I'm encoding at the remote location, every camera feed that comes in needs to be encoded. And if I'm then moving to decode those at this remote location, I need to go and make sure that my computer has enough bandwidth, enough horsepower to decode all of these. And then you're also limited by your aggregate bandwidth that you have for up and down with all of these cases. But with this set now, you'll notice that here it's telling me I have 2 sources that I'm taking in as well. So very, very simple framework and very easy to monitor everything that's going on when you set this up. The other thing that is really great is you can do it all from one location. So if you have a remote system, once you turn that system on and make it part of that remote network, you now can do any additional configuration right here in the studio. So it has kind of the advantage that Dante has, where in an AV environment, you can manage all the routes from one location. The same thing here with Bird Dog Cloud. And that can be really, really useful as you set all this up. But some of the other things, because I definitely want to talk about a few things. So we did talk a little bit, I mentioned about port forwarding. So just to explain what port forwarding is, when you are dealing with your typical network connected to the internet, you have one public IP address. That's the address that traffic is routed to get to your location. But then internally, every computer you add has what are called private IP addresses. Addresses that can't be routed over the internet, but allow you to identify individual systems inside your office or facility generally. And so when you make a request, like if box A goes and tries to load a web page, what happens in your router is that request to get a web page goes to the router, and it will translate that into here's my public IP address, and I'm going to create a special port on that, which is basically a number, up to 64,000 ports that I append to that when I send that back and get a return response, I can look at that extra port number and say, okay, that port number actually goes to this computer. And it does that automatically. And those ports are called ephemeral ports because it happens for that transaction. I'm making a request and it creates the port, watches it, and then when the response comes back, it gets rid of the port. It doesn't exist. What port forwarding lets you do, though, is it lets you create permanent ports on your router that when you talk to a remote location, you can tell it, if you want to talk back to me, talk to me at this public IP address, the one common one you have for your facility, but at this specific port now. And by putting those two things together, when that router receives any packet for that port, using port forwarding, it says, okay, this has to go to this machine at this private IP address. And that's how that port forwarding works. So when you set this up, you can have SRT in these connections. All you need to say is, if you're the caller, call me at this IP address and this port, and I'll let you through. And that will get that signal back to the computers. That's what port forwarding does here in the context of the broader network connection. So the fact you can do that all locally and you don't have to do that remotely is great. So the other thing talked about a bit was the ability to set up different types of encoding. So let me jump in here. And when we went into this initially, we said, well, we're just going to use the default because we want to get back to that. So what you get with encoding is the ability to describe exactly how I want to create, how compact a signal I want to create to send over the internet. So the more that you compact a signal, typically the more you lose quality and you can't recover that at the other end. So you really want to strike a balance between this signal is small enough data-wise to easily get to the other side without losing information, but it's big enough so that the information that I make a conscious choice to lose doesn't impact the image quality that much. And so there are lots of things here. So you can give it a name. So this is just your way of remembering these encoding settings that you're setting up as a custom encoding. And I can say, well, what bit rate? So right now I have this set at 5. The default is for 10. I could set this up, if I have great internet and can work, I could set this up for much larger, which you probably would if you were doing things like 4K video. I can then say, what type of bit rate do I want to use? And the bit rate mode is two types, variable bit rate and constant bit rate. So variable bit rate can shrink or expand the number of bits used to describe any, used to describe video inside any given packet, but it can vary from packet to packet. And that can be based on how complex a scene is. So if I have lots of sharp edges, I may need more bits to adequately describe those transitions inside a video image. And so it can make better use of bandwidth. Constant bandwidth is more generally used. And so if you select constant bandwidth, it's going to say, this is going to use the same amount of pixels to describe any image, no matter how simple or complex that image is. So that's, you have the ability to change that. And then we get to the video encoding. And so baked into Bird Dog Cloud are NVENC for H.264 and H.265. So if you have a more powerful GPU, you can certainly use H.265 because that will give you better compression without as much loss in quality. And so you have that, or H.264, and you can do the same for QuickSync. So if you only have an Intel chip and you don't have an NVIDIA GPU, it will work with that. And it also uses VP8, which is sort of the Google open standard for, it's what WebRTC would use at its most basic. It's sort of every system, if you're going to say you're WebRTC compliant, you have to have VP8. So it gives you different types of options for how you want to do the encoding. And it also gives you different profiles. So I'm not really going to go in. This isn't going to dive too deeply into the encoding specifics, but there are all different types of profiles you can use that give you, trade-off size for quality. And so you can pick, whatever types of profiles you want. If there are different, types of presets, so I can go compress, encode this using higher performance, which means that you're going to, you may be trading quality, but it encodes quickly. So if your system is slower, you may need to turn around and say, okay, don't compress it as much, and we'll just live with poorer quality. These are the types of trade-offs it lets you make, and in GOP size and other things here. And then you can just save this. So you could set up to one site, which has great internet connectivity. You could set up high bandwidth, more demanding encodes, but to cameras you connect to at another location with poorer quality internet, you could jump and say, okay, I'm going to set this up as a different type of profile. And that's exactly what we did here. So, if I come back, let me just jump over here, actually. When I set these up, I had the choice. So let me just go and edit this. I had the choice to select which profile. So in the default, that could be, the 10 megabit. But if this were a poorer connection I need to go to, I could set this up and go, well, we're only going to use 5 megabits and fit everything into that. So this makes it very easy with these pre-configured compression profiles, how to set everything up when you want to connect cameras and everything else. So let's talk a bit about use cases here, because we've really gone through the general framework of how all of this works. So in one of the terms that has come into vogue with remote productions is something called REMI, and it's remote integration model. So basically a general kind of nomenclature for anything where video sources are a different location from where you process them. So, but there are different ways that people may actually want to use this. Actually, there were a few questions here, so let me jump in before we get to this next piece. So Matthias asked, what's the big difference compared to LiveView? So both LiveView and BirdDog Cloud are doing the same basic kinds of things, but how that transport takes place is very different. So LiveView will do the same compression through encoding. So I believe they have H.264, H.265 baked in to the LiveView units. However, the transport protocol is where the real difference happens. What LiveView does is it will take multiple, that one video stream, and split it across multiple individual cellular connections. So those cellular connections are what's called bonded. So what that means is that I can have 2, 3, 4, I believe there are even LiveViews with even more, that will have those multiple connections operate as one large bonded internet link. And the data that goes through that then, if one goes bad, one drops out, one has congestion, that information just gets routed across the others. So you don't need to sort of, when you have a one-to-one link, if that connection goes bad, you're in trouble. With LiveView, because it's using multiple cellular connections bonded together, it gives you that flexibility. And that's why you pay more for the greater number of cellular connections you associate with a LiveView unit. And the other thing is, this all has to go through LiveView's backend, because effectively what has to happen is LiveView has to take those multiple cellular connections and repackage them into a single hardwired connection, which will come back to a studio. So that piece is also different. LiveView is using a proprietary backend loop, and BirdDog is using the internet, though you could certainly use it across any general connection That's the baseline difference between the two. And that's why LiveView is great in these mobile situations, because it's making use of cellular bandwidth across multiple cellular connections. So you get sort of the best possible signal you can untethered from a wire. So let's see here. Uh, so Dennis from the Netherlands. Dennis, thank you. I appreciate you joining us. We have Andrew from Johannesburg. Andrew, thank you. Appreciate you being here. So, J.S. Gilbert, are there additional use fees or some sort of use limit in addition to the annual fee that BirdDog charges? So, the BirdDog model from a commercial side has a few dimensions to it. So the first one is that you pay for each endpoint that you set up. And that typically is $1,000 a year is the license fee for each endpoint. So if you have two locations talking, those are two endpoints, so $2,000 a year is the commercial model there. You can have as many connections between those two endpoints as you want. So if you set up an endpoint as a monster computer and you were pumping 8 camera feeds into that, no difference. That is fine. So there's no additional charge. BirdDog Cloud, because unlike LiveView, we were just talking about it, where that connection is going through LiveView's back end and they have a direct cost associated with that, BirdDog Cloud is going through the internet. So there really isn't a charge on BirdDog. There's no cost scaling if you send more feeds or fewer feeds through that licensed connection. So the business model makes sense where you can have as many connections across those two endpoints as you'd like. BirdDog Cloud also has other elements in here that we really didn't talk about. They have something called Cloud Connect, which I believe runs using WebRTC, and there are additional charges for that. And BirdDog Connect Cloud Connect is really around more for monitoring. So if you wanted to send a reference video to somebody in a studio at another location who was just looking to make sure everything was going well, you could do those types of things. And that requires a separate license, and you have to have some provider in the back end for making that WebRTC connection happen. So there are other charges associated with that. But you actually can do a lot, when you have each one of those connections within the framework. Like they have something for presenter mode, which I think is really cool, where you have the ability to tell it, take these two NDI feeds and bundle them up where there's a little window, which will be my presenter, and the big window, which could be my slides or a screen capture or something. And you can have it send that to a remote location. So, there are different ways that you can make some of these things work that are, clearly beneficial given the circumstances that are bundled in here. And of course, the ability to monitor and control everything from that single location is great. But, okay, so let's just talk, sort of to wrap this up, let's talk about a few of the use cases that you would normally have. So one of them is what a lot of people come to associate it with remote productions, which is deploying my studio up on AWS. So when you do that type of deployment, all of the systems, so I could have like vMix, and I could have Live to Air, and I could have another graphics system for doing lower thirds or other things. I could have control systems up there for signaling to do control. When I have all those set up, they will normally, if they're moving audio or video, use NDI. So that would all have to be configured there. But anything that's coming in, if they have remote cameras coming in, video feeds coming back to a location that they want to stream to, that they want to present on a wall, whatever else they want to do, that would all be based on SRT. And so BirdDog Cloud would be an excellent fit for that, because you can basically set all your gear up and then just use BirdDog Cloud as there would be one endpoint up there, and you use BirdDog Cloud to route everything in and out of that AWS instance that you'd want. So definitely great use case there. Another one would be where you actually want to have your production studio in a central location. So the traditional production studio style. But I want to send somebody out with all my cameras, and I'm going to use this, you know, do all the switching remotely. Well, this could be a conference, it could be a sports event. This also became popular for people that really weren't ready to go full cloud deployment, but because of the restrictions people had with different types of live gatherings, they would send out a very small crew and just set up cameras for individual guests, and that's how they'd switch everything then back at their studio. Similar to AWS, just with a sort of a physical presence in a traditional studio. And the other, which has actually been around a long time, is a distributed production. And where this came in is a lot around sports, where you would have people that would do like the CG stuff, all the graphics, scoreboards, lower thirds, all the other stuff. You could have those people working from a home location. You could have somebody else switching in a studio location, and then somebody on site with the play-by-play announcers, with the camera operators, and they would all come in from these different locations into the single studio location. So similar to the second model, but just with potentially more individual component pieces involved. So this would require more endpoints under Bird Dog Cloud, which could ramp up the cost, overall for some of these things. But given the cost of travel and having people at locations, that could end up being something that's definitely valuable. So, okay, so let's see here. Yeah, and the other thing, which we really haven't touched on, isn't really live stream, is people who may be doing different types of editorials. Say, if you know that NewTek has supported things like Adobe Premiere with NDI in and out. So you could, for instance, be using this to stream proofs of videos to an editor and from an editor to a client at another location, where they could go over it sort of frame by frame and say what they like and what they don't. So hopefully this gives you some things to think about. As I said, the trial is free, and I definitely encourage you to download it, start to play with it, and see if there's something something there for the types of productions that you're working on. Oh, we have so let's see. So JS, so placing a director or producer downstream then makes them an endpoint. So yes, as far as I understand it, in the Bird Dog Cloud model, anywhere where you would want to route video and audio to, or take video and audio from, would make them a different endpoint in the mix. And this is going to be something where that would probably be two-way if you had directors or producers. So different ways to do this, and it really depends on the quality. So if you were doing something like this, you could have like directors come in with using live to air or vMix call or something like that, where you don't need to have a high bandwidth video signal for them, and you can deal with things like dropouts or other things that could happen across a non-optimal connection that you could have. So this is something that definitely you should bake into the economics, but there really is a lot of trade-offs with deploying people, paying for gas, shipping the gear, setup time, teardown time. So all those things have an incremental cost. And if you look at an endpoint as being something that's less than $100 a month, the economics could very easily work for that. So, okay, so I think we're just about ready to wrap up the show. So why don't I invite everybody, please, if you have any other questions, I definitely, happy to answer them in the post-show here. If you can stay around, that would be great. If you can't, please know I'll see everyone next week for that. But why don't we jump to the post-show, and we'll dig in a bit more and take any other questions that everybody has. All right, so welcome back to the post show here. I'm told we have a caller, so uh, let me see if we can get them on here. Welcome back to the post show here. I'm told we have a caller, so okay. So sorry, just taking a second here.
Hi, how you doing?
Hi, how are you?
Well, great. I'm just actually one of the viewers that are from Guatemala, and just wanted to
Hi, how are you
say,
doing? Hi, how are you?
I'm
Well,
great, thank
great.
you.
I'm just actually one of the viewers that are
I
from
think we got
Guatemala.
an
Audio looping back here, so let's.
Yeah.
Okay,
Okay.
okay. You may need to turn it down just a little bit on your side, and then we.
Here we
Okay,
go. Here we go.
good.
Yeah, I just wanted to say to we appreciate all your knowledge that you shared with us. I learned a lot from the show actually, and we have many questions in our Spanish community. But for now, I just wanted to say thank you and appreciate all the effort that you guys and your team put on this every week show. You
Oh,
know.
thank you. I appreciate. I, everything that makes this worthwhile is people that are taking it and doing something with it. So we love the fact that you're finding things that are useful here, and that
Yes.
you can make this into something that actually benefits your productions, and that's really the goal in everything we do. It's just we believe that the more people understand how to use the tools they already have, uh, the better off they are. And then every decision you make to buy something new is not based on, I didn't know I could do it or do it this way. It's
Right.
based on, now this really fits into the overall workflow. And you sort of build a sustainable business that way. And I think that's for everybody in this space, that's key. And
That's correct. So I appreciate it very much, and thank you for showing me right at your screens.
well, well, thank you very much for calling in. We definitely appreciate that. So
Thank you.
thank you. Take care, Hecky.
Goodbye.
Bye. All right, so that was Heki Teki. I've seen uh, Heki Teki around in the Facebook forums and other places, so that's always great to see somebody call in. So this was interesting because when we had a client that came to us last week and said they were looking to uh, set something up with BirdDog Cloud, and so we actually dug down and started to do some work with it, and actually, we knew about it and we had seen some things on it, but once we got sort of under the hood and started to play with it, we were really impressed. And so this is something, we said this would be great to share because I think for a lot of people, uh, while there may be other ways that people can do it for less money, sometimes the time factor and the flexibility factor can override the expense of a single component. So we want to make sure that we at least covered this and sort of put it out there as an option for you to play with and explore. But there are a lot of great use cases when you start to think through how these types of technologies, SRT in general, can be used. And I mean, so one of the things that we've been looking at is using the encoders and decoders, the NDI encoders and decoders, as endpoints, and seeing how much we could do that would actually not involve having to have computers at different locations. And there are cameras that have SRT built in. Uh, there are others that you do need some type of encoder around this, and so that's definitely a set of options that you have available. But I think when you put everything together, there can be some pretty cool infrastructure enhancements you can do where you minimize the number of computers, maximize the number of connection points, and find great ways to make all this stuff work. And, you know, clearly the big question everybody's going to have is going to be, well, what's SRT versus NDI bridge? And we know that this is definitely something that is going to be playing out. And I have to say, this is a good thing on a lot of fronts because it makes each one of these camps really push themselves further. And that, as consumers of these technologies, that's great. So, so let me see. J.S. Gilbert. So, yeah, J.S. Gilbert says pretty soon the world will be one big data center. I believe we're there. I think everybody is walking around with a cell phone, which is just an untethered endpoint in our lives, and so we're all connected to each other. Uh, so let's see. Mady, thank you for joining us. It's great to have you here. So everybody's doing very well here. So here stateside, we're going into the long weekend. It's the 4th of July. So for everybody in the States or from the States that celebrates 4th of July, we wish everyone a very relaxing time. It's a great time for friends and family. So hopefully you have something good planned for this weekend. But just to wrap up, if there are any other questions anybody has, please post them up there. But as I was mentioning, we're really keen on a lot of what's going on with encoders and decoders around NDI. BirdDog actually announced a new encoder called the BirdDog, I think it's Player, and we have a couple on order. They're not available yet, but we definitely want to dig in because some of the things that may be available there is you may be able to connect to the cloud directly through that. So I don't really know. We don't have one on hand. But got another thing from J.S. Gilbert. How do you handle back channel communications with the whole team? Okay, there are lots of different ways to do that. So one of them could be using something like Discord, where you could have multiple people connect to channels, and they could all hear and talk with each other. Some of these could be things you can do with Dante, where you can actually have multiple receivers from a single transmitter. So that would be more one-way communication, and then you'd have to set up a second channel back. So outside of using solutions like IP solutions from ClearComm and other things, which definitely have a role in the production space, but could certainly be pretty expensive. Those would be different ways you could do things around that. The other, believe it or not, is people use things like Zoom, where you have everybody just sort of jump onto a Zoom call and it's just audio and you just talk to each other like a big conference call. So different ways to do that. And with Zoom, you get things like Zoom rooms and other stuff where you can sort of break people up potentially. So you could have different groups with different conversations and somebody who could drop in sort of across them. So different ways on all of these things to do back channel communications. Some of them very old school, some of them a little janky, but yeah, they're like Jay said, they use Zoom now. So, but there are lots of different ways to do this. And again, I'm very much in favor of putting money behind what shows up on camera. So if you can save some money with some of the crew communications, but put that money into something which is going to give you a better video image or better audio or more flexibility for some of the things you want to do, that's the stuff that actually impacts what people see and ultimately is what we're all judged by. So definitely something to think about as you allocate budgets around the different things you're doing. So I'm going to say again, there's Toika. If I'm saying your name, it's in Cyrillic, so I apologize if I cannot say it right. This is definitely great to have you here. So thank you for joining us. So yeah, so J.S. Gilbert said, based on what it used to take to deploy teams, $1,000 an endpoint a year, actually isn't a lot. And I think that's the point. I mean, in gas alone, to a distant location, 80 or 90 bucks in a month is could be could actually be a steal. So definitely something as you think about it, because when you say a number like $1,000, people are like, ooh, okay, I'd rather look at something free. But when you start to think of how this can impact the overall production and ways you can save money, well, without sacrificing that on-screen quality, that's great. So, so the headset. Matey's asking about the headset we're using. Uh, it it is a it is a DPD headset. I'm not sure the model number. Uh, so I I actually uh, I actually like the headset as it really it's not as good as an onset mic, but it gives me a little more flexibility when I move or lean over or do any type of demo thing. So I think the trade-off is good with that. But this is we're open to going to different things. But we were actually happy when we heard this one compared to some of the other options out there. But I know other people who use Countryman and other similar style models and are happy with that. So I think there's a set of options out there. So let's see. So I have so Tom Sinclair. Oh, Tom Sinclair just dropped in and said hi. So Tom, thank you very much for for joining us here. I definitely appreciate you tuning in here. So and I know probably everybody in this space knows Tom, but if you have not yet tuned into Streaming Idiots, it is quite the treat. So definitely, if you get the chance, look over in the Streaming Idiots group on Facebook. Incredible value there as well, because a lot of smart people sharing a lot of very clever solutions for things. So definitely drop in there as well. So let's see. Yeah, Jay Skibber said that there's a price for quality, and that's true. It's making sure that whatever you get does does match up to the price you're paying, but there everything that has some level of quality has an associated cost. And again, I think that's the difference between when you move from something as a hobby to doing it where people are paying for specific results. That's something you have to factor in, and it does make a difference. The quality you deliver on screen matters, and people will see that and recognize you for a level of quality and sort of associate value with that. So these things do come around, and it may not be immediate, but as people see the value, not just in the quality of the signal, but the quality of the production, the quality of the content. So quality sort of comes in a lot of dimensions. And so that's something, definitely as you produce, you'll get to appreciate, where it matters and where it doesn't. And you can, focus on the places that have results. So let's see, Matey has, asking about, okay, so this one is, the Army UFX was not happy with the sound. Any suggestions for making tutorials? So, I'm not exactly familiar. I mean, RME typically is a high-end brand, so I not familiar specifically. We use, I mean, there's multiple things in our sort of stages, audio stages. That we're using. So we use the DBX 286S's. So that allows us to sort of play with compression, gain staging, and get a hopefully a better signal. We're still dialing that in. That's audio is an ongoing exercise for us. So we're always working on that side to it. But yeah, I mean, I probably should think about doing some more tutorials on this end as well around audio processing, because there is a lot, and we learn a lot as well when we do these things. So it probably would be good for us as well. Sorry, I don't have a more specific answer to the UFX Plus, but definitely something I can look into as well. So if it's something you want, just reach out to me. So, Mady he said, one more question. What picture profile are you using? The skin tones are great. So this is not S-Cinetone. It is basically it's a Rec 702 with some tweaks that we're using. We are using a Blackmagic Pocket Cinema 4K, and so we sort of dialed it in and tweaked it a bit to get the tones a little bit better. But that's what we're using here. But now the S-Cinetone, I've heard nothing but great things about that, and we've actually thought about bringing in like an FX3 as a camera here as well, because we just think it's the full frame Sony lineup is really incredible for a lot of this stuff. So the images that you can get from some of those cameras is awesome. So definitely something we are thinking about as well for different ways to sort of improve quality and color matching cameras, which is always it's a heartbreaking endeavor, because you always think you're close, and then when you look at it with slightly different lighting, everything is off again. So not something that I could specifically say I'm an expert at, but we do try. So yeah, so I think everybody. So I have Mady is saying the A7S3s, and JS Gilbert also are saying the A7s are amazing, and I mean we agree. We love the Sony lineup, and it's something that I think once you are invested in the ecosystem, it just pays dividends. You can start to use the glass is great around that, typically from Sony, and the sensors, the low light performance, like lots of things to like about that. Autofocus. I mean, autofocus is almost seamless with most of those for video. So great stuff on that. So let's see, JS, you also mentioned the Rodecaster Pros are nice for running audio for live streaming. Yep. I mean, Rodecaster, definitely makes a lot of nice audio gear. We have some mics that we use for mobile things. We love their wireless. So the wireless Go 2, where you have two transmitters to one receiver. Great, and the very strong signal, great distance. All of these, of course, break apart when you're at NAB and there are a million people broadcasting from a show floor and stuff like that. But in most normal environments, they are fantastic. So, all right. So, just going to wrap things up then for today. We actually are going to have a really interesting show next week, just sort of a sneak peek. We have Lee Love will be joining us. Lee is a photographer and videographer who has his own show called photomentor.tv that he has a great organic, artistic view to the technology and the way people use it. And this is definitely going to be a fun show, and he's got so much knowledge on so many different fronts. So would love to have everybody join us here. And JS Gilbert, absolutely looking forward to seeing everybody at NAB this October. That's after missing last year. It's going to be a lot of fun to reconnect with people, and I know there are a few events out there as well. So there's going to be Streaming Idiots. I know PTZ Optics is going to have a Stream Geeks booth, I believe. So that would be really cool. So a lot of fun stuff that goes on out there, and a lot of great people that are doing doing a lot of good in this community. So a lot of fun. So, oh, Mady just threw in, it says, the FX6 if you need the built-in ND filters. Yeah, that is the one thing with the Sony FX3 is sort of their small cinema line. It's basically a re-engineered A7S3, more button designed around video production versus stills. But yeah, it doesn't have built-in ND filters, so you have to do that externally somehow. So definitely it gets more expensive with the FX6. So you sort of go from 4,000 to 6,000, not counting the glass. So in for a penny, in for a pound, maybe. But I'd have to see if I could justify that type of budget. But all right, everyone. Thank you very much for joining me today. Hope you found this useful. I'll see you all next week. Take care. Bye.